Hello friend, today we discuss GATE 2024 1 mark previous year question discussion. So this is very useful for the recent pattern followed by Opsc for mechanical paper, just like assistant working engineer or motor vehicle inspector group A post. So Opsc follow the pattern by bringing the 1 mark previous year question from GATE. So this lesson is particularly for solving 1 mark question and which is very useful for Opsc prelim paper. So let's start the 1 mark question for from previous year 2024. So the first question is the velocity field of two-dimensional incompressible flow is given by the velocity vector is 2 sin hxi plus vxy j cap, where I and g denote the unit vector in x and y direction respectively, and vx0 is cos hs and v0 minus 1. We have to calculate it. The options are 1, 2, 3, 4, and this is topic from the fluid kinematics from fluid mechanics. Let's start how to solve and how to approach this question, and this is also 1 mark question from fluid mechanics, and chapter is fluid kinematics. So the given data is the velocity is 2 sin h sorry then this is two-dimensional incompressible flow, and given vx0 is equal to cos hs. Also vx is equal to cos hx, and we have to find v0 minus 1. This is two-dimensional incompressible. So this is incompressible flow. So we have to satisfy the continuity equation. The continuity equation is del v is equal to 0. That means del u by del x plus del v by del x, जो del v by del y equal to 0. So this is u and this is v. So del u by del x is equal to del by del x of 2 sin x plus del v by del y is equal to 0 sin hx, sorry, hyperbolic. So the derivative of 2 sin hyperbolic x is 2 cos hx plus del v by del y is equal to 0. That means del v by del y is equal to minus 2 cos hyperbolic x. So del v is equal to minus 2 cos hx del y. So by integrating both sides, we get the velocity vector v is equal to minus 2 cos hx, as this is the y function, so treating as a constant. So minus 2 hx coming from outside, the integration of del y is to y plus constant. This is equation 1. From this boundary condition, we get v x naught is cos hx. That means cos hx is equal to minus 2y cos h x, and the y value is 0 plus c. So this is 2 into 0 into cos hx, the whole term will be 0. That means c value is cos hx. Putting this value, c value, constant value, in equation 1, we get v is equal to minus 2y cos hx plus cos hx. Simplifying this, cos hx common, 1 minus 2y. This is v value. So we have to find v at 0 and minus 1. We get cos h 0, 1 minus y value minus 1. We get cos h naught value is 1 into 1 minus 2 into minus 1 is minus 2, and minus of minus 2 is plus 2. So 2 plus 1 3 into 1. That means v at the rate 0 minus 1 is equal to 3. So the answer will be 3. So option C will be correct answer. Next question we have to discuss. Consider a incompressible laminar flow over a flat plate with free stream velocity u infinite. The Nusselt number corresponding to flow velocity is nu Nusselt 1, and if the free stream velocity is doubled, then Nusselt number changes to Nusselt number 2. Then choose the correct option for Nusselt number 2 to Nusselt number 1. This is chapter from heat transfer, and the chapter is flow over plate and pipes. So let's start solving. So we know Nusselt number is from laminar flow 0.332 into Reynolds number power 1 by 2 and Prandtl's power 1 by 3. So we know Reynolds number formula is rho and u infinity length of the plate divided by mu. So as Reynolds number is directly proportional to u infinity, that means free stream velocity, so and Prandtl's number is also a constant quantity. So Nusselt number in formula is directly proportional to Reynolds number power 1 by 2, and Reynolds number is directly proportional to u infinity. So Nusselt number directly proportional to this free stream velocity power 1 by 2. That means Nusselt number is directly proportional to this stream velocity root over of this. So this is the relation, and the question given, if the free stream velocity is doubled, then Nusselt number changes to nu2. So in the first case, Nusselt number 1 is directly proportional to u infinity 1 root over, and second case, Nusselt number 2 directly proportional to u infinity 2, and given data u infinity 2 is equal to 2 times of u infinity 1. So we can write Nusselt number 2 is directly proportional to u infinity 2 value is equal to 2 times of u infinity 1. This is equation 1, then this is equation 2, and from equation 1, Nusselt number is equal to some constant k root over of u infinity 1, and from 2, Nusselt number 2 is equal to some constant root 2 bahar, take it outside, and u infinity 1. So this is Nusselt number 1. So question asks Nusselt number 2 divided by Nusselt number 1. Nusselt number 1 is k into root 2 times u infinity 2, so this is 2, divided by k into root over of u infinity 1, this is 1 and this is 1, as u infinity 2 is equal to root 2 times of u infinity 1, so this is u infinity 1. So u infinity 1 unit cancel, k cancel, so Nusselt number 2 divided by Nusselt number 1 is equal to root 2. Answer is root 2. So the next question, the furnace can supply heat steadily at 12,000 Kelvin at the rate of 24,000 kilojoule per minute. The maximum power output in kilowatt that can be using heat supply by furnace in an environment 300 Kelvin each. As this is the heat engine, please let us draw the heat engine. This is clockwise, and this is produce some W net by taking some heat input from a hot reservoir TH and reject to sink temperature TL with Q out. So for maximum power output, that means we have to follow the Carnot cycle. That means efficiency maximum, the formula is 1 minus TL, lower temperature of sink to higher temperature of source, which is equal to W net divided by Q in. Given data TH height is equal to 12,000 Kelvin, all data are Kelvin, and Q in is equal to 24,000 kilojoule per minute, and the environmental, that means the ambient temperature, that means the lower temperature is 300 Kelvin. So from that equation we get 1 minus TL is 300 divided by 24,000, 1200 is equal to W net divided by Q in. Q in is 24 kilojoule per minute. So let us convert this minute into second. That means, okay, this will be calculated in next step. This is 1, this is 4, so 1 minus 1 by 4, W net 24 kilojoule per minute, that means divided by 60 kilojoule per second, and that which joule per second is watt, that means kilowatt. So 1 minus 1 by 4, 4 1 3 by 4, this is 3 by 4 is equal to W net divided by 6, 400 kilowatt. So W net is equal to 400 into 3 by 4 is equal to 100, 100 into 3, 300 kilowatt W net. So option A will be correct answer. Next question. For a ball bearing, the fatigue life in million or revolution is given by L C by P power n, where P is the constant applied and C is the basic dynamic load rating, and which one following the true. And the given data is ball bearing. So we know for ball bearing n value is 3, and for roller bearing equal to 10 by 3. This is roller bearing, this is ball bearing. So either this or this will be correct, and this are the, and for that condition and this is the P is constant applied and fatigue life. So outer racing is fixed and inner racing is revolving. So option C will be correct answer. This is subject for machine design. Chapter is bearing. Next question. Which one following theory is the most conservative design approach against fatigue failure? Options are Soderbergh, Modify Gouvernement, Gerber, Illigny. This is from also machine design. Chapter is static dynamic loading and failure. And we know this is the stress amplitude, and this is the mean stress, and this is the straight line which is cutting SYT and SE. SE means endurance limit, and the YT means yield point stress, and this is also yield, and UT is ultimate. So this is the Soderbergh line. That means the equation is SA by SE plus 1 by factor of safety. So this is the SM, this is SA, this is cutting at SC, and this is cutting at SY, and this is the minimum area, that means towards the origin. So this is also most conservative. The Gerber parabola fit the parabola point just at the best possible way. That's why this is Soderbergh line is most conservative line. So options A will be correct answer. So that's all for today. In the next class we discuss remaining all 1 mark question that's which will be very useful for the upcoming exam for OPSC especially. Thank you.